Version 2. Alright, so I did a video the other day how to level the bed on the K1 Max and also how to adjust the belt. But I came up with a better idea of how to do it. Now that I went through it once, and I was very long-winded, and the video was a lot longer than I intended it to be, and I went on tangents, and I didn't finish thoughts, and probably all the other reasons that I lost half my subscribers. No. Anyway, I have a better way to do it, and now that it's a second try, it's going to be better. All right, a couple close-ups here. That video, this video, that video. I don't know which way I'm editing it yet. Did not show up close some things. So, first of all, to check the reference angle. So you just stick the magnetic protractor to the rod. And so we got point 30, bubble to the left. Then you put it on the bed. And point 35, bubble to the left. That's just about perfect. And then similar for the XY. Put it on there with magnetized. And 0.06 bubble to the rear. And 0.0 bubble to the middle. Again, very close. So the references are the rods, and then the bed, get your measurement. And then you're adjusting the, basically if I'm going to the y-axis, I would say, okay, I want it to be whatever number. And I was just grabbing this screw like this and turning it to make the bed go up or down there. That's all I was doing. And then once I had it, for example, if I was turning this one, once I had it in place, I just took a clip, put it underneath so it can't go down. And then I took another clip, and you can use a bunch of different types of clips. I'll use a different clip just to show what I mean. I can use a small binder clip, put it all the way down against the nut. And so now I can't go up or down, so that locked that into place. And that's what I was saying by locking this lead screw into place. It's called a lead screw. In this video, I'm going to show the new and improved way to much more accurately level the bed on the K1 Max, and a lot less fiddly, as they would say across the pond, with a lot less wasted steps. All right, so basically, you're going to pull the filament spool off. That's no brainer. Unplug it. All right. This is my glare deflector there. Kind of looks like a trash bag, but it's actually a glare deflector. All right, so I unplugged it. And, all right, at some point I want to get a reference of the leveling. And so I will do that right now. So basically, to measure how level it is, you measure the bed in two directions, the X direction and the Y direction, referenced off of the guide rails in the X direction and the Y direction. So, for example, this guide rail says it is 0.28 degrees, bubble to the left. If I go over to here, 0.2, yeah, it's floating around 1/4 of a degree. And that is 0.3 degrees. So it's actually very close already, because I leveled it the other day. But I want to redo it this way to make a better video. And that is level 0.01 to the back and 0.5 to the front. All right, so we are 1/2 degree off in the Y direction. And that's not bad. I did some math. Okay, 0.58 to the front. I forgot to check it to the other side here just to see. 0.15 to the front. So yeah, we're like 1/2 degree off, front to back, Y-axis. And I did the math, as I mentioned that I would on the CAD. And for 1 degree off, a foot apart, so basically the full width of the bed, if it was off by a degree, it ended up like 0.2 inches, which is quite a bit, or almost like 0.21 inches or something like that. So not quite a quarter inch, but a significant amount. So that half a degree, that's still going to put me off like a 16th of an inch or something. I'm sorry, like an eighth of an inch, which is pretty significant. And that's not linear, so I'm not sure, give or take, eighth of an inch or so off. And so I'm going to dial that in even more right now. So I want to, so yeah, unplug it, so you don't electrocute yourself, but also the plug is just in the way. And take the spool holder off the back. I actually left the filament. You probably can't see that. The filament is still attached. So basically what I'm going to do is pop this cover off. I'm going to loosen the belt tensioner so the belts can easily skip. And then I'm going to twist the rods by hand to get it exactly where I want it. So I'm not even at the mercy of quarter turns on the nut. If you look at my other video, I took the 4 screws out like we have 3 Z-axis rods, right? And there's a nut on each of the rods, and then there's 4 screws on each nut. And so you can unscrew those screws and turn the nut a quarter of a turn and put it back in, or 3/4 of a turn and put it back in, put the screws back in. And so then you're sort of limited to that 90-degree steps on each nut. So you get them pretty close. And I ended up half a degree off front to back. I probably could have done better, but it is what it is. I could come up with some excuses, but instead, I'm just going to show a better way to do this today. All right, so we have 6 screws here to take off. So taking the 4 screws out from each nut was quite tedious. And so this is going to be, because they're, not only is there a bunch of screws, they're also right next to the lead screws, the Z-axis lead screws. And so you're coming in at an angle and you're cramped for space, and it's just not ideal at all. So this is 6 screws here that are very easy to get at. These 4 corners, and then this one and this one. And then there's 2 more screws on the tensioners there to the belt tensioner. You just loosen those a couple turns. So you don't have to take those all the way out, and those are also very easy to access. So this is much quicker and easier, I'm sure. And I usually like to work with power tools. Don't have one handy. So this should just about fall out. There it goes. Oh, we have a wire. I almost forgot about this. We have a wire to this fan. I would potentially unplug it, but I don't want to forget to plug it back in. So I'm going to leave it connected. All right, and then we have the 2 for the tensioner. Yeah, that's just a little slightly larger screw. And so basically, so the belt is like a big capital T, right? And so that's the motor that drives the 3 Z-axis screws. That's the rear Z-axis screw that goes up to the top of the printer from here. I say top, we're laid down on the back, so this is the bottom, top is in the back. And so that's the rear screw, and this is the front right screw, and this is the front left screw. And then you can see the belt is a big capital T around all of those, and this is a tensioner and a spring on the tensioner. So so the spring sets the tension initially, but then you have to lock it in with these screws. So I loosen these up, and so if I push down on this tensioner, which is a little tricky to do, you know, I think I need to loosen these screws a little more because they kind of get a little, the way screw ways get a little deformed by the screws. So I should be able to push this down and loosen the belt. Now it's nice and loose. So now I'm going to tighten this. Wow, that's that spring is stronger than I thought. So basically, I'm pushing this tensioner down. You got to push with pretty good force there. Then I'm going to tighten these locking screws back up with it very loose. And wait till this is, I like what I've come up with here. I hope it works as good as I think. First time trying it. So I have now locked the belt very loose. So I should be able to just turn the screws and have it skip teeth on the belt. And so now, you know what? I am going to unplug this fan just because I need to flip it back up right. And I would have to put the screws back in. So rather than put the screws back in, I'm just going to disconnect the fan. And we can all laugh when I forget to reconnect the fan. Okay, I think I have this figured out. All right, so take the top screw out of the adjuster because that limits your range of motion more. Loosen the bottom screw. Okay. Take the needle nose pliers. If you can see where I put that, on both ends of the spring basically. And now I'm just going to compress the spring as much as I can. And then tighten this screw. So right now the belt is super loose. And you got to squeeze pretty good on this, so you might want to phone a friend. It's a little tricky because it kind of bows out. I'm probably going to break the thing. Do this at your own risk. I might break the spring perch off, but it's I'm just overcoming the spring force, so I'm saying it's strong enough to hold up against the spring, so it should be loosening as we speak. Okay, that's how it's going to go. Should get it to there. Squeeze it a little more, then push it on. That's how we're going to do it. Okay. Let's just move quick. Measure this, remeasure this, again. Turn that on, get my light on. Side to side, we are 0.26 bubble to the left. We're at 0.26 bubble to the left. Nice. How about front to back? This would be funny if I took it off when it was fine. So 209 bubble to the rear. 0.86 bubble to the rear. So I gotta adjust this screw to 0.09 bubble to the rear. 0.58. 0.45. Ooh. It's actually, why did that turn? Is that my imagination? 0.09 bubble to the rear. I mean, it looked like the front one moved, but could have been my imagination. 0.09 bubble to the rear. 0.1 bubble to the rear. Perfect. Side to side. 0.21, 0.19 bubble to the right. 0.27 bubble to the left. Okay. Evidently, somehow, the left front one turn. 2.7 bubble to the left. 0.2 bubble to the right. Okay, that's fine. Let's move this down until it's 0.27 bubble to the left. Oh, I see what's going on. So it's not the belt that caused the other one to move. So I do need to sort of clamp those. I did find a little bit better of a clamp. I found this little clampy guy. much more amenable to our purpose. If only I had more of them. So, in any case, I'm going to put this guy on here. And so that should no longer go up or down. Let's see where we're... Well, let's lock that guy in, and then we'll level to that guy. All right, where do we need to be? We need to be 0.27, bubble to the left. And we're 0.03, bubble to the right. So if I go down at this, so I want to get it to 0.27, bubble to the left. That's 19. 0.23. 0.25. 0.25 to the left. And 0.28 to the left. I'm calling that perfect enough. Okay. Ooh, I saw a lightning flash. Cool. All right. Now I need to lock that guy in. Okay. And if I push those down a little bit. So now I just threw it off maybe. 0.28 bubble to the left. 0.27 bubble to the left. Perfect. All right, and now I have the front two can't go down really unless I actually moved the clamps. And so now front to rear, well, I need to check the reference first. Always reference to the rail. So 0.09 bubble to the rear. No, I gotta let it settle to 0.13 bubble to the rear. 0.72 bubble to the rear. So let's go to 0.13 bubble to the rear. .4. .08. And 0.14 bubbles to the rear. And 0.12 bubble to the rear. Okay, let's confirm that the side to side is still good. So 0.28 bubble to the left. 0.28 bubble to the left. All right, we are so dialed right now. More clamps of the proper size would be awesome. Ooh, I got another one of these tiny ones. I got this guy. That one looks pretty useless. I have various clamps here. So now I can clamp the top of this guy. Clamp the top of this guy. So now there's resistance for either way to go, either of the two front ones to go up or down, and the rear one to not go down. Ah, nice. One more little clamp. So I'm going to put a clamp on the top. Be real nice if we're still recording. And we are. Okay. So I have all three dialed in. Okay, and of course the belts fell off. But that's hopefully fine. Get on there, belt. Trying to... As I put these belts back on and then tension them, I want to turn these as minimally as possible. And there's probably going to be some calibration. It's probably going to, because it's going to turn the two front ones slightly in opposite directions, I suspect. And I'll really be able to figure out. So when I measure it after and I see how much they're off from each other, then I should be able to see how much they get turned in by changing the adjustment. Okay. And It looks like this has already shifted a bit. So now I'm canting the pliers downward so that I'm flat under the bottom, and the top is pushing it at an angle. I think that's just less likely to break things. And I'm really just trying to compress that spring, really focus on compressing that spring as much as I can. Mosquito on my leg. Get on there. There we go. Oh, no. What was that? I guess maybe the tensioner moved a little bit. Almost there, man. Almost there. Get on there. So close. Ah! I had it so close. Digging a hole in my thumbnail with this end of the shaft. Man, you could have gave me a little more adjustment on this belt there, Creality. So I got it on one side. I really don't want to turn it on. Nice. So now tightening these up will probably move things around a little bit. It's just going to have to be acceptable. So now if I loosen this screw. Some. And probably, I think it deformed the slide there, so I probably have to push this in. Oh, so let's loosen this up more. There it goes. So now the tensioner has freed and moved up to where it's resting. I can see that I deformed that groove a little bit, and it should be fine because I also have the second. Okay. I think I have dug myself out of all of the holes that I dug for myself. Except for I don't know what this part is. If anybody recognizes this part, I don't know what it is. I don't know if it broke off or it's just a... This looks like some kind of retainer clip. I don't know. That's how things go sometimes. Spare parts. Okay. Let's tighten that guy up. Tighten this guy up. Doesn't have to be super tight. Now, the moment of truth. I said the moment of truth. And this whole bottom cover seems like spare parts to me, right? Oh, but I need the flobbery feet. So let's check this. See if we're anywhere near still level. Would be nice if we are. So left to right, we are 0.2 to the left. Bubble to the left. And we are 0.3 bubble to the left. I call that a win. How about in the y-axis? We are 0.3 to the bubble, 0.28 bubble to the rear. Oh, Oh, that scared me. 0.27 bubble to the rear. Nailed it. Just about perfect. So obviously you have to be careful when putting the belt on that you don't accidentally move things. But with the clamp on the top and the bottom of everything, I think that's the key. And that was my basic idea. Loosen the belts, to summarize. Loosen the belts, clamp one screw into position, level it side to side to that, clamp the second screw in position, then level front to rear, then clamp the third in position, then put the belt back on. Because my initial thought was, so now I can pull these clamps off. My initial thought was to loosen the belt. I thought it was going to be super easy because I could just loosen the belt. And it got tricky because loosening the belt wasn't quite enough for my, well, with my results anyway. Did I not clip that? Oh, the bottom clip fell off, I guess. Yeah, okay. Bottom clip fell off, which is fine. Bunch of clips back there. So, did I finish my thought? Sorry to do that to my viewers. I want to reiterate that. Take the belt off. Lock one axis in position. One screw, I should say. We have 3 screws for the Z-axis. Lock one in position, one of the front ones. Because the front ones are leveling side to side also, whereas the rear is only one screw leveling front to back. So pick one side or the other, lock it in place, take your reference angle from here, take your reference angle, get that number, put that there, level this guy by turning that screw. That screw is fixed in place. Turn that screw until that's level. Then clamp this guy in place. So now both of them are clamped into place. Then take your front to rear reference measurement. Then take your front to rear bed measurement. Turn that rear screw until the number matches the reference number. Then clamp that top and bottom. That screw, top and bottom, so it can't move. Then flip it back on its back. Put the belt back on. And take your clamps off. And if you did it right, this thing appears to be perfectly flat. Now, I don't have the network enabled on this, so I don't see the mesh. And maybe I will do that. But it seems unnecessary to me because I just measured it and it's about perfect front and rear. So I guess... Okay, and now I need to plug it back in. Muy importante. Okay, we're plugged in. And then I just need to recalibrate. Always remember to recalibrate, because if you don't recalibrate, then if you don't recalibrate, you probably crash into the bed, or you'll just be way off the bed, and you will fail. I recommend not failing. Although, who was it? Some wise guy said, I don't know, Ben Franklin, Aristotle, Socrates, I don't know. Somebody said, show me a man who's never failed, and I'll show you a man that never did squat. And you can quote me on that. And I probably destroyed my inlet tube here. Let's put a good bend on that. Might want to be more careful than I was on that. Oh, I didn't put my feet back on. Aha. And I'm going to unplug this again, because I didn't put the bottom back on. Forgot about that somewhat important part. So let's go back to here. Am I recording? Yep. Take a sip of Popeye spinach. Nailed it. That's okay. And belt's tight. Tensioner's tightened. Where's the thingamadoodle? What do I do with my panel? Okay, I somehow lost my bottom panel. I don't know how you do that. That takes talent. Bottom panel? Anybody? Ah. Bottom panel. Okay. And like so. And put this guy back in. Can't really tell. I mean, it's got to go that way. Usually you can tell which way the wire goes by its memory, by its shape memory. Okay. So much for the shape memory thing. That is now there. And I guess this guy. This panel is somewhat shifted downward. There we go. All right. The other way of, so it's the right size, yep. Because the nut screws, the lead screw nut screws were much more of a hassle to remove and reinstall. Due both to their, mainly because of their proximity, their very close proximity to the lead screws themselves. Very hard to get at. Ideally, you're listening to this in high speed. Cool thunder effects. Can you hear that? Okay. Let's jack this guy back up. Plug her in. Find the switch. There's the port. We have power. And I'm gonna put the spool peg back in. Spool peg back in. Might as well throw the filament on there while I'm thinking of it. Well, bent my guide tube there a little bit. People like to call it a Bowden tube. But I still say, while sometimes those Teflon tubes are used as Bowden tubes in the non-direct drive extruders, I'm not sure it's properly called the Bowden tube as applied in this situation, because it's only a guide. It's not used to transmit force, push and or pull. It's just a guide. I believe if you look up the definition of a Bowden tube, a Bowden cable is a coaxial arrangement. This is my definition, not necessarily matching exactly in the dictionary, but I would say the Bowden tube, a Bowden cable, is a coaxial cable arrangement for the purpose of transmitting force axially. And we are not transmitting force axially. We are simply guiding filament. Like, you could take that tube out and the extruder will still bring the filament in without that tube. That tube is only a guide, therefore not transmitting axial force, therefore not technically a Bowden arrangement. Therefore, feel free to call it a Bowden tube. But I'm just trying to share a little bit of knowledge on there. All right, we are good. I just need to calibrate, self-inspection, auto leveling, start inspection. Are we still recording? We are still recording. Oh man, I forgot to suck it up. Forgot to suck it in all that video. Man. All right, well, thanks for watching. I don't think we're quite done. We'll probably do a test print. I'll probably make I'll print that test part one more time and measure the thickness at the four corners and add that to the end of the video. But that doesn't mean I shouldn't say right now, if you made it this far, please do everybody a favor and click the like button, because it helps people to find it, helps grow the channel. And I think this video is a lot more useful than the previous video. Previous video, I know when I watched it, I was annoyed at myself just for, there were too many times where I didn't finish a thought, or I didn't finish the thought properly, or I went on a tangent and never finished the thought, and did things. I was just doing it on the fly as I was figuring it out. I didn't look at any instructions. All right, this is where I give my list of excuses, and I could give a whole lot more, but anyway, I was just exploring it based on logic, and then once I went through it once, I realized there's an easier way to do it, and so I did it the easier way, and hopefully I was able to be more concise and finish my thoughts and go on minimal tangents and to make it useful. And so the previous one, I believe, was an hour and a half, and no big surprise that people don't necessarily want to watch that an hour and a half with an hour worth of bloopers. And this probably took me another hour because, again, I was trying to figure it out, but at least hopefully I was more concise and all that, and coming out pretty good. And so be sure to share it with your like-minded friends, and maybe hit the notifications if you don't want to miss any of my ramblings. But hopefully this is useful and add some value, and if so, help the channel grow. So stay tuned for more. All right, so here is our resultant part after the second bed leveling process, and I am going to harvest this bad boy and take some measurements and see how it compares to the previously leveled method, bed leveling method, and then the pre-bed leveling method when the belt was too loose from the factory, which is weird because it made it a long time. It worked fine, but eventually caught up with me. But we'll see. We're going to measure these and see how they compare. Okay, so I have here my 3 test samples that I just happened to print. I don't know if it was this one or this one. I'll be able to tell by how crooked they are. A test piece, and it didn't fit right. And I said, why doesn't it fit right? Well, it turned out that my bed was very out of level, and so my print thickness varied significantly. So I believe this is the latest. I'll measure that one last, and I can probably tell by looking at these. So one of them I broke the top off, but I think that was the second one. And I'm going by, I'm not going by the overall height, I'm going by the thickness here and here and here and here. And it seems to me that one of them will just look obviously not uniform, but it's not. I'm guessing this is the first one. So let's see. I believe the measurement was supposed to be 0.61. So let's see. We're zeroed out, and that is at 0, 0, 0. Okay. If I go to this corner, we are at 0.562. Now, again, it's supposed to be 0.61. So that's 50 thousandths off, basically. 0.562, 0.578, 0.595, 0.59, 0.56, and in here, oops, 0.52, 0.52. So it's supposed to be 0.61, it's 0.52. So yes, this is the first one. It's supposed to be 0.62, I'm sorry, it's supposed to be 0.61, and it's 0.52 at the worst spot that I can measure. Might even be a little worse if I had the right place to measure, but I can only measure 3 sides of this because this did not have the step in it yet. This one actually has the step, so this one I can actually measure all 4. So that one varied from 0.5. What did I say? 0.52. 0.52 at the worst, and diagonally across 0.6, 0.598. Yeah. So 0.6. 0.61 is supposed to be 0.6. And now, of course, this isn't the whole width of the bed. All right, so from 0.52 to 0.6. So under to way under. Now this one is 0.62, which is over by 10,000. It's supposed to be 0.61. 0.598. 0.62 here. And 0.61 there. So that's pretty close. But, so what was my range? Range 0.62, 0.596. So, plus 10, minus 15, or something like that. Now this one, and I haven't measured this yet, 0.604, 0.606, 0.61, right on. And inside, what's going on there? 0.61, dead on. 0.61, 0.606, 0.604, 0.61. So this, that's how you level the bed. Just saying. You're welcome. All right, didn't mean to be cocky, just trying to be funny. But if you like this video, if you found this value in this, and if this levels your bed properly, please share with your like-minded friends. Click the like button, subscribe, click the notification bell, all those YouTubey things. And I look forward to seeing you on the stats and in the next video. Thanks for watching.